in this question we are told B to D is 2 O to B's. So O to B is called B. B to D is 2 lots of that, so it must be called 2B. M is the midpoint of OA. So O to A is called A. M is halfway. So that means O to M is going to be half of an A, and M to A is also going to be half of an A. It splits O to A in half. A to P is K times A to B. So it's a fraction of the whole journey. So A to P is a fraction of A to B. Given MPD is a straight line, from M to P to D is a straight line, find the value of K. So find what fraction A to P is of A to B. To do this, we're going to use the fact that if this is a straight line, MPD is a straight line, M to P and M to D must go in the same direction. One must be a multiple of the other. So that's what we're going to use here. So we're going to have to work out what M to P is and M to D is. So let's do that. So how can I get from M to P? I'm going to have to use, well, A to B. So let's work out A to B first. To get from A to B, I go minus A plus B. And so A to P, we've been told in the question, is K times this. K times A to B. So it's going to be K times A to B. It's some fraction of that. We don't know what K is. That's what we're working out. We're working out K. That's A to P. I want M to P. So I'm going to go half an A and then this. So M to A is called half of an A. And then I want K times minus A plus B. M to P is M to A and then A to P. So that's M to P. How about M to D? So M to D. So I want to go backwards half of an A to get to O. So backwards minus half an A, and then forwards 3 B's. That's M to P and M to D. So we can say one's a multiple of the other. And I can say, let's change M to D. So I can change M to D into M to P by just multiplying it by something. It's some multiple of M to P. I don't know what X is. It's just some multiple of it. M to D is M to P in the same direction, but multiplied by something. So now I've got M to P twice. I can either say it's this or it's this, and those two things must be equal. So these two M to P's, they must be the same thing. So I can say half of an A plus K times minus A plus B is equal to X times minus half A plus 3 B's. And I will expand these brackets. So half A, K times minus A is going to be minus KA. I'm always going to write my A's and B's on the end. K times B is KB. X times minus a half A is minus a half XA. Again, I'm writing the A's and B's on the end because X and K are just numbers. They're just numbers. We can work them out. But A and B are the vectors. They're going to stay as A and B. And X times 3B is 3XB. So this still looks complicated, but because we've got A's and B's, the A's must be equal and the b's must be equal. So we can actually split this off into two equations. We've got a's and we've got b's, and we can split them off into two separate equations. So we can do one equation for a's. So how many a's do we have on the left hand side? We've got half minus k. We've got half minus k. They're all a's, we don't have to write a. And on the right side, we've got minus a half x. And for our b's, we've got k equals 3x. So we've got simultaneous equations, and we can solve them to find k. That's what we're looking for. We're looking for k. So, well, we want to eliminate x. We want to get rid of x. So I can make, well, there's different ways of doing it. It doesn't matter how you do it from here, as long as you find out what k is. So I think I want to get rid of the fractions first. So if I double everything on this equation, so double every term, so 2 halves make 1, 2k's are 2k, and 2 minus a halves make minus 1. So I've got 1 minus 2k equals negative x. I really want x to be positive. Actually, I'll leave that as it is, and I'll get x by itself on this one by dividing both sides by 3. So k over 3 equals x. So I can change x into k over 3. X is equal to k over 3, so I can substitute that in. So if I substitute k over 3 in for x, I've got 1 minus 2k equals negative k over 3. I'm going to get rid of the divide by 3 by multiplying everything by 3. So 3 minus 6k equals negative k. Then plus 6k to both sides. 3 equals 5k. And divide both sides by 5. K is 3/5. And that's the answer. That's what we were looking for. We were trying to find k. So a to p is 3/5 of a to b. Okay, here's another one. We've got a, b, c, d, which is a parallelogram. M is the midpoint of CD. So M is the midpoint of CD. And the opposite sides on a parallelogram are equal. So we must have A to B is 4A. D to C must also be 4A. So D to M must be 2A. And M to C must be 2A. P is the point on BC. So on BC, such that B to P is 1 part. So 1 part, and P to C is 2 parts. So 1/3 and 2/3. The whole journey is 6 B's. So 1/3 must be 2 B's and 2/3 must be 4 B's. B to P is half of P to C. X is the point on PD. X is the point on PD. So P to D, X is the point on this line, such that P to X is a fraction of P to D. So it's K times P to D. I won't write that on just yet because it says AXM is a straight line. So A to X to M, A to X to M is a straight line. So X must be here. And again, we know that AXM is a straight line. So what we can do, we can go A to M and A to X. and then use the fact that one's a multiple of the other, which will give us our simultaneous equations again. So let's just work out a to x and a to m. So a to m is going to be easier. A to m is going to be 6b plus 2a. Now a to x, we need to use k. So p to x is k times p to d. So we need to go p to d. So if we do p to d, and then we can work out, well, we can say p to x is k times that. So p to d is 4b's minus 4a's. P to b is 4b's minus 4a's. So p to x is k times that, k times p to d. So k times 4b's minus 4a's. So we're using axm. So we need to take this route. We need to go a to b to p to x. So we need to write a to x as 4a plus 2b plus p to x. So there's a to x and a to m. We know they're a straight line. So we can also say a to x is a fraction of a to m. And we can call that x. So x times 6b plus 2a. So we've got a to x twice. They must be equal to each other. So we can write them as equal to each other. So we've got x times 6b plus 2a equals 4a plus 2b plus k times 4b minus 4a. Expanding the brackets, we've got 6xb plus 2xa equals 4a plus 2b plus 4kb minus 4ka. So we've got an equation with a's and b's in it. So we can separate them off. We can say a terms on the left are equal to a terms on the right. And b terms on the left are equal to the b terms on the right. So if we just look at our a's, just look at the a's, we can say 2x is equal to 4 minus 4k. We're not writing a after each of them. This is all in terms of a. These are all our a terms. And our b terms, we've got 6x equals 2 plus 4k. We want to find k. So if I multiply this by 3, I can get 6x equals 12 minus 12k. And I've got 6x equals and 6x equals. So I can write that as 12 minus 12k equals 2 plus 4k. So 12 minus 12k equals 6x, and 2 plus 4k equals 6x, so they must equal each other. So that's plus 12k to both sides. 12 equals 2 plus 16k. Take 2 from both sides. 10 equals 16k. Divide both sides by 16. So k is 10/16 or 5/8. So k is 5/8. So P to X is 5/8 of P to D. And another one, P is the point on OA, such that O to P, so on OA, O to P is 2 parts, and P to A is 1 part. X is the point on AB, such that A to X is 3 parts, so 3/5, and X to B is 2 parts, so 2/5. O to D is a multiple of O to P. O to D is a multiple of O to B. And PXD is a straight line. So P to X to D is a straight line. So that should have been there. Let's redraw X there. Right. So let's work stuff out. So we can go from P to X and P to D, and then use the fact they're a straight line, so one's a multiple of the other. So P to D is minus 2/3 A, and then O to D is K times O to B. O to B is called B, so O to D, that whole journey O to D, is K times B. So plus KB. P to X is 1/3 A. I should have worked out A to B first. I'll leave that for now. A to B is minus A plus B, and A to X is 3/5 of this. So 3/5 of minus A plus B. So P to X is 1/3 A plus this, plus 3/5 A, 3/5 of minus A plus B. So 1/3 A minus 3/5 A plus 3/5 B. We've got 1/3 minus 3/5. So if we want to add these fractions, we're going to multiply top and bottom by 5. So 5/15 A, and multiply top and bottom by 3, 9/15 A. So 5/15 take away 9/15 is going to be negative 4/15. So we've got negative 4/15 A plus 3/5 B. That's our P to X. And we're going to use the fact that P to X and P to D, so these two, are a straight line. So one must be a multiple of the other. So I can say that P to X, this one, times something makes P to D. So P to D is something times this answer, minus 4/5 A plus 3/5 B. So now we've got two things in terms of P to D, two P to Ds, so they must be equal to each other. So minus 2/3 A plus KB must be equal to X times minus 4/15 A plus 3/5 B. I'll expand this bracket. So minus 4/15 XA plus 3/5 XB equals minus 2/3 A plus KB. So we can now separate this out into one equation for A's and one equation for B's. For these two things to be equal, the A's must be equal, and the B's must be equal. So we can find out, well, we can find out what X is if we multiply both sides by 15. So that would be negative 30 thirds equals negative 4x. So negative 30 thirds is negative 10. So negative 10 equals negative 4x. X is negative 10 over negative 4, which is 10 over 4, or 5 over 2. So x is 5 over 2. So k is 3/5 times 5 over 2, which is 3 over 2. So O to D is 1.5 times O to B. So k is 3 over 2. And we have one more question. ABCD is a quadrilateral. M is the midpoint of C to D. So M is the midpoint of C to D. X is the point on A to M. On A to M, such that A to X, so X is on here somewhere, such that A to X is K times X to M. So A to X is K times X to M. So we're looking at how many X to M's make A to X. That's what the question's saying. Given BXD is a straight line, B to X to D is a straight line, find the value of K. So again, as before, we're going to use the fact that B to X and B to D are multiples of each other. So we can work out B to D by going 2a plus 2b plus b. So 2a plus 3b. That's B to D. And we want B to X. So let's go A to M first. A to M is A plus 2a plus 2b plus half of a b. So A, 2a plus 2b, half a b. So that's 3a's and 2.5 b's. So 5 over 2 or 2.5. That's A to M. A to X is a fraction of that. It's not K of that. So let's not use K. Let's use X. So we can say that A to X is a fraction of A to M. We don't want to use K because K is how many times X to M is multiplied to get A to X. So let's not use K, let's use X. So that's A to X. We wanted B to X. So B to X is minus A plus our last answer. And we can use the fact that BXD is a straight line by saying B to D, a fraction of this is B to X. So we'll use another letter for a fraction. We'll use Y this time. So Y times B to D equals B to X. Because they're on the same straight line. So it must be a multiple. So now we've got two b2x's. We can make simultaneous equations. So we can say y times 2a plus 3b equals negative a plus x times 3a plus 5 over 2b. And if we expand the brackets, we've got 2ya plus 3yb equals negative a plus 3xa plus 5 over 2xb. So we can split out our a and b terms. We can say a's must equal a's and b's must equal b's. So we have for our a's 2y equals negative 1 plus 3x. We don't have to write the a's, they're all our a's. And for our b's, 3y equals 5 over 2x. So we want, well, we want to find x, don't we? We want to find x. So let's get rid of y. And if I multiply this equation by 3, I'll get 6y equals negative 3 plus 9x. And multiply our b equation by 2. Multiply our b equation by 2. We get 6x equals 6y equals 5x. So they're both 6y equals. So we can make them equal to each other. Negative 3 plus 9x equals 5x. So let's subtract 5x from both sides. Negative 3 plus 4x equals 0. Add 3 to both sides and divide by 4. So x is 3/4. So we know a to x is 3/4 of the whole journey. So we must have 3/4 and 1/4. What was the question? A to x is what is something times x to m. So if we've got 3/4 and 1/4, we have to multiply x to m by 3 to get a to x. So that means that k is equal to 3. So k is equal to 3.